direct variation, where things were directly related to each other. So as one thing grew, the other did at a constant rate. But inverse variation is a little different. As one thing goes up, the other thing decreases. So if you look at the area of a rectangle, we have 2 times 3 is still an area of 6, 6 times 1 is an area of 6, and 12 times a half is still an area of 6. As 3 increased to 6, 2 had to be chopped in half. If we have 6 times 1, it's equivalent to 12 times a half. If we doubled the 6 to get 12, we need to reduce the 1 by half so it stays balanced. So all lever problems, or seesaw problems, involve inverse variation. You have a fulcrum point, and we want to balance weight number 1 and weight number 2. And these two things are not equal. So how do we know where to place the fulcrum in order for these to balance? Well, we have to know something about distance 1 and distance 2. If the product of those two is equal to the product of these two, then you will be able to perfectly balance it. Let's go and look at a little example. We have a 1 kilogram weight and a ½ kilogram weight, and they are perfectly balanced on a nice little meter stick. How did we do this? Well, let's try a problem over here. We have 2 weights, 9 pounds and 12 pounds, and we want to balance them. The 12-pound weight is placed 6 feet from the fulcrum. So we've got our 12-pound weight times 6 feet away. We've got a 9-pound weight times a mystery distance. What is it? Well, let's set them equal. 9d equals 6 times 12, which is 72. Let's divide both sides by 9. And we get that the distance should be 8 feet away. You can do it with a real seesaw, too. If you have a 20-foot seesaw, all right, it doesn't have to be drawn to scale, and you have Gabriella, she's a wee, she weighs 105 pounds, and she is 9 feet away, all right? Michael is a little heavier. He's 140 pounds, so he's going to need less distance because she needs to leverage his weight. But we don't know what his distance is, so let's use D. Let's set them equal. 140 equals 9 times 105. 140D. Don't forget your D. I'm going to divide both sides by 140. And if you don't have a calculator, now is an appropriate time to cancel things out if you know how many times 5 goes into 105 or something like that. I happen to know that 7 goes into 105 15 times. And I happen to know that 7 goes into 140 20 times. And so if I had to do this multiplication problem, I would cancel one more time. 5 goes into that 4, 5 goes into that 3, and my answer would be 27 over 4. Well, how many feet is that really? Well, do the division out, and you would get 6.75 feet, or 6 feet and 9 inches. So check these answers out and get ready for the quiz.